Now let us talk about how groups can be formed in permutation and combinations. Let's say if we have to distribute m plus n plus p different objects, it can be divided into three different sets of m, n and p. Then what would be the number of possible ways of distributing them? It would become m plus n plus p whole factorial divided by m factorial, n factorial, p factorial. So this diagram would also explain you the same thing. So before that, let me just write it down for you. Let's say if I have to distribute m plus n plus p different objects to be divided into three groups of m, n and p objects, then their permutation would become m plus n plus p factorial divided by m factorial, n factorial, p factorial. Now if I was to give you an example to make you understand this, let's say I have 10 and I need to distribute 10 into two groups. One group has 3 members and other one has 7. I had 10 people. I'm distributing them into two groups. One group should have 3 people and the other group should have 7 people. So what is the way of or number of combinations in which I can distribute them? It would become 10 factorial divided by 3 factorial into 7 factorial. So this is what I mean to tell you about formation of groups. As you can see here, A, B, C, consider this as M, N and P. If I was to distribute them in 3 groups, considering one is M, considering one is P, other one is N, then how many ways can you distribute them again? So that would be a permutation and combination. Let's do a question based on this concept. It would clear all your doubts. Let's say we have 8 persons who are to be transported from city A to city B in 3 cars of different makes. If each car can accommodate at most 3 persons, so first of all we have 8 people, there are 3 cars, that means we have to distribute them in 3 different groups. So in one of the group there are going to be 3 people, other one as well 3, and in the last one there are going to be 2. Because there are 3 cars and there are 8 people, so we need to distribute it in this order only. Then the number of ways in which they can be transported is. So first of all, let us write down about the cars. Let's say I have to transport from A to B. I have 3 cars, right? Car 1, car 2 and car 3. Now what are the ways I can distribute them? Either car 1 takes 3%, car 2 takes 3% and car 3 takes 2%. Or car 1 is taking 3%, car 2 is taking 2% and car 3 is taking 3. Similarly, it can be 2, 3, 3. So there are 3 ways in which they can be arranged. So the number of ways, so total ways, firstly it simply can be written down from this formula only. It would become 8 factorial divided by 2 factorial, 3 factorial into 3 factorial. Now since these through 3 groups that I've distributed it in, they can also be divided into 3 different parts like this one. So there would be a multiplication of 3 as well. I hope this portion is very much clear. So if you try to solve this out, the answer would come out to be 1680. I'll repeat it again. So first of all, there were 8 people. I had to distribute them in 3 groups, where one group had 3, other group had 3, other one had 2. Now it is not fixed which group has 2, which group has 3 and which group has 3. So again, now there are 3 different groups, out of which 2 are having the same number of people. That means I can arrange them in 3 different ways. Basically, if let's say it would have been not 3, 3, 2, if let's say all these 3 numbers would have been different, then I would have divided it into 3 factorial ways, right? Now here what we did was, instead of 3 factorial, we wrote this 3 as 3 factorial by 2 factorial. Basically, this is what we did. And apart from this, as we studied in this formula, formation of groups, 8 can be divided into 3 groups using this formula, 8 factorial by 2 factorial into 3 factorial into 3 factorial. So by that we got our answer. Let's now jump into another topic, combination of alike objects. Now again, let me take that basket example that we were taking. 2 oranges, 3 watermelon and 4 mangoes, let's say. Earlier at the first, when we did this type of formula where we used 2 to the power n as our formula, what was we doing there? We were finding out the number of ways in which we can collect fruits. Now that includes collecting 1 fruit, collecting 2 fruits, collecting 3 fruits, collecting up to 9 fruits as well. Now here what we are saying is that if there are, let's say, 3 types of objects inside any out of which 2 P are alike, Q are alike, R are alike, S are different, then the total number of combinations of picking at least one of each object would be. So that means I have to pick 1 orange, I have to pick 1 watermelon, I have to pick 1 mango. So what would be my number of combinations then? This would be the formula. Now here what they've told us that S are different. However, if I was to take this example, here what would be my total number of ways? My ways would become 2 plus 1 into 3 plus 1 into 4 plus 1 minus 1. Now 2 to the power 0 would be here because as number of different objects are 0 here, so that wouldn't be considered. So this is how I find out my combination of alike objects. Let's look at this example to understand better. Assuming the balls to be identical except for the difference in colors, the number of ways in which one or more balls can be selected from. That means we have to select one or more. That means there is no chance of us selecting a 0 ball, right? So inside we have 10 white, 9 green and 7 black balls. So we have to choose one or more balls in each and every turn. So what would be my number of ways? Now here again, simply we just use our formula, which is 10 plus 1, 9 plus 1, 7 plus 1, minus 1, 2 to the power s. This becomes 0 of course because there is no different objects inside. This would become 11 into 10, 110 into 8 minus 1. Ultimately this would give us 879. 879 as our answer. Fairly simple. I hope you must have understood this. There is nothing much concepts involved here, simply a formula which we have to use. Now let's look at this one. This is known as a rank problem. Mostly questions that are asked in JEE are asked from rank problems only, and this was also one of the previous year JEE mains question. Now of course I cannot explain this concept without using an example, so directly I've taken up an example. All the letters of the word public are written in all possible orders, and these words are arranged in dictionary with serial numbers. Then the serial number of word public would be. Now how do we solve these type of questions? Now the serial number, basically this term here, this means that we have to find out the rank of the word public in the dictionary. What would be its rank? So what is the way of solving this type of question? First we arrange the letters of the word public in the dictionary order, like in ascending order. So what would be the first letter that would come? It would be B, then we would have C, then we would have I. B, C and I are gone. Now then we would have L, then we would have P, and then we would have U. So this is my arrangement in dictionary order, alphabetical order. I hope you are understanding this. Right now I haven't done anything. Firstly I'm just arranging it in dictionary order. Now to find out my rank, what do I have to do is I have to first fill in one letter, then find out the number of ways in which other letters can be arranged, and then continue on till I find out the word public. So what I will do here is, since I have 6 letters here, first I will take my first letter, it is B. Does my word public start with B? No. That means 1, 2, 3, 4, 5. There are 5 ways in which I can arrange this, so this would become 5 factorial. Now again I will go again, I will check for C. Is this the correct one? No. So this would again become 5 factorial ways. Now I will check again. What is my next term? It is I. For I again it is not correct, so this would again become 5 factorial. For L again it is not correct, so it would become 5 factorial. Now for P, Now when I write P, it is correct. It is correct. Now I am not going to add anything here. Now I would start checking for the second letter from the first alphabet itself. Now P is correct. Now I do not need to add anything. Now I start checking for the second alphabet, P, which starts with B. So B, PB, is this correct? No. So how many are left? 1, 2, 3, 4. So this would become 4 factorial. P is correct. Now C, is it correct? No. Again 4 factorial. Now I put P and then comes I. Is it correct? No. Again this becomes 4 factorial. P, L, is it correct? No. Again it becomes 4 factorial. Now P had already been taken in the first place, so you can remove P from your finding out. Now after PL, since you cannot repeat P was only there once in your word. Now we would have U, and U is correct, so we wouldn't do anything here. Now again we would start for the third letter from the start. Now let's look for B. Again this is also correct, so we do not need to worry about this as well. Now we'll search for the fourth letter, C. Is this correct? No. So number of words left 2, so this would become 2 factorial. P, U, B. After C, so B is taken up, U is taken up. I am having I. Is this correct? No. Again 2 factorial. After I, what do I have? L. Is it correct? Yes. So now I will move on to my fourth letter. Now again C comes in here. Is this correct? No. This would again become 1 factorial. Now I will check again. P, U, B, L. Now C was incorrect. Now I. Yes, I is absolutely correct. So I becomes correct here. And then I is gone, L is gone, and now C is left. So C would also simply come here. Now once your word is completed, you would simply add a 1 as well. Now what we are going to do is we are going to add all these up. 5 factorial plus 5 factorial plus 5 factorial. All these we are going to add up, and that is what our serial number or our rank is going to be. So this would be 582. This would become our answer, and this is our serial number of the word public. I hope you must have understood this. Let me repeat it once again. You received the word public. You have to find out the rank of it. What do you do first is arrange the letters of the word public in the ascending order, alphabetical order. You would have B first, C, I, L, P, U. Now start analyzing from the first letter. First I put B. Is my B correct? No. So the number of spaces left, I have to add a 5 factorial to my number of ways. Then I check for the other one, C. Again it is not correct, so I again added 5 factorial. Similarly I did for I, L till I reached P. Once I reach P, I do not have to do anything now. Now I would start with the second letter. Now for the second letter, I again start with my first one, B. And once I found out P, I will simply strike off P from my letter list. Then B, again it is not correct, so 4 factorial because 4 letters are left out. Similarly, we do it until we get U. U is also correct. And then we come for the third letter. Third letter B is also correct. Then we come for the fourth letter, C. C is incorrect, so the number of letters left out, 2 factorial. Similarly, we go on to do this till we get our correct word, which is public. Once we get our correct word public, we would simply add a 1 there as well, because the number that we have found out, that would be the rank minus 1. We are actually finding out the number of words that would lie before public. So to find out the rank of public, we have to add 1 there as well. That is why in the end we added 1 as well. That is why we got 582.